and then we started system call. Okay, and I did not explain what is system call. If you take any system call, see here in this diagram. In this diagram, they have given a system call read system call, which is called a read system call. Okay. So any input operation is there in your program. That program will call the read system call. Okay. So input device can only read. Okay. So that time with the input device, there will be a connection established, and the processor will retrieve the data from the input device. Okay. So this operation is a sensitive operation because it is communicating with some hardware input device. So that it should be the system call should be created. Okay. So by taking which example we are going to see this read. Read is a system call. System call, as I said, it is a function. Okay, so function will have parameters. You can call function or method. Okay, with the parameters. So function will say mainly what you have to write. See what you have to do. That particular function will perform what. So that is read. Read is a main operation it has to do. But to do this operation, there are some additional attributes it needs. Okay. So those attributes or those variables are these FD, buffer, n bytes. Okay, this is a file directory where actually the file is stored. We can say this is the file name also. This will have file name also. Buffer is the address. This is value. The first and last parameters are value. Second parameter is the address. So after read some data from the input device, the data should be temporarily stored in a buffer. Okay. Then from the buffer, the processor will take the data. Okay. So once again, students. Okay. So buffer, from the input device, the data will be taken. The data which the processor wants to read, that will be taken. That will be taken and kept inside the buffer. So in which address of the buffer it should be stored. Okay, so that is the second parameter. Third parameter, how many number of bytes, n bytes means number of bytes should be read. Okay, so the file may have many data, many lengthy data, but in that which particular data should be read. So that is the last parameter. First parameter file name, second parameter the address of the buffer where actually the data should be stored after retrieved from the input device, and then how many number of bytes should be read. Okay, so these are the parameters. Students, are you all hearing me? Am I audible? My voice is clear, students?
Yes, ma'am.
Yes, ma'am.
Okay. All should listen. In between, I randomly call and I will ask the questions. Okay, so everyone should listen. I will ask questions. So how many? 68 of you are there. Students, how was the literary event? How many of you attended? How many of you won any of the event? Because this is the first time you are attending the event, no, college fest. How it was?
It was good, ma'am.
Okay, may I know how many of you participated? You won or did not win, that's the second thing, but how many of you participated? At least in one of the events. Because we did not conduct the lectures that was announced as a non-instructional days only because you all should participate. Okay. So I want to know how many of you participated in how many events. Yes, Abhishek, Aishwarya, Arya. I want to know. Tejas said he participated. In which event you participated?
Ma'am, I participated in visions in gaming.
Okay. What about others? Ifat, Aishwarya, Sanya. Why no one is talking? No one is giving any reply. See, later we have to give report from the department. Okay, the report should have how many students participated in how many of the events. Just like that, they will not they will not cancel the lecture. Okay, so you must have participated. How many of you participated? I did not ask how many of you won in the event. Okay, I asked how many of you participated. Yes, yes.
I also participate
In which event?
in gaming only, ma'am. COD.
Okay, fine. Others, only two. 71 students are there. Out of 71, only two. Huh? What about others? Students? You were informed about all the events, no? Not only our department event, others also. You were informed about, right? The links were shared. Yes, Trisha messaged something on. Even I have participated, ma'am. Okay, Trisha, in which event you participated? Art competition, very good. What about others? Only 3 participants.
Ma'am, I participated in Epicures event.
Parvati, okay, fine.
I also
Others?
in Epicures.
Something Purva, you said something, right?
Yes, ma'am.
You also participated in any event?
Yes, ma'am. Epicures.
Okay, fine. You and Parvati, okay. What about others? Glory, are you there? Glory? Glory? Ajil, are you there? Ajil or Glory? Both of you are not there. Okay. Students, after the lecture, any one of you just inform to Glory to message me personally. Okay. Okay. Students, remember, if you participated and won in any of the events, it may be inter-college, in inter-college competition or intra-college competition, you have to inform to the class teacher. Okay. If you won, definitely you have to, because we have to keep the record of that. Okay. So remember. Okay, we were seeing about the system call. Okay. So read is a system call. which has three parameters. It is not necessary all the system call should have parameters. Okay, if required, it should have. Okay. So now how these system call will be executed. Okay, so that we are going to see. Now see, read system call. In this diagram, they have given the steps. There are 11 steps. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, then 11. Okay, so this one system call has 11 steps. How it will be exactly executed. Okay, so assume that this is a memory. Okay, so this is the library procedure. For example, you will import the library files, no, in your program, std.io, hash include. So all those are what some, because you studied C, that's why I'm saying. So those are system calls. Okay. Sorry, those are library files. Okay, so you import the library files, no? So that is like that is given here. Okay, library procedure read. Okay, so this is a not complete library file. It is a portion of the library file which is related to only the read system call, read procedure. Okay, and this is actually your program. Okay, so internally what will happen in your program? This is a library file, header file, and this is a program. And here you see this is the kernel mode, or we can call this is the kernel space of the operating system. Okay, kernel space of the operating system. One second. Okay, so this is a kernel space, and this complete is a user space. Okay, you know, operating system will work in two modes, either kernel mode or user mode. Okay, when it will go to kernel mode, any sensitive instruction should be executed, or any high priority interrupt the processor got. Then being in coming inside the kernel space, it has to execute the kernel instructions. Okay, so this is a user space and this is a kernel space. Okay, and this is a user program. This is the library file which you imported, or you can call this the header file, or you can call preprocessor directive. Okay, so now how this will be executed when the read system call enabled. But in your program, with respect to what programming language you are using, whether you are using Java or C, C++, Python, whatever you're using, depending on that, the input statement will vary. Okay, whatever the input statement, the system call will be read system call. Okay, but remember the name of the system call and the parameters will vary operating system to operating system. Okay, so here in the entire book, as I said, we have taken Unix operating system call. Okay, so which is coming under POSIX API. Okay, if you have taken Windows, then that will come under Win32 API. That already I said. Okay. So what will happen first? These three parameters should be pushed inside the stack. Okay, stack is a memory portion in the main memory. Okay, first the system call After the system call enabled, that means the first, second, third, first 3 steps. Push n bytes, push address of the buffer, push file name. Okay. So all these parameters, input data, will be pushed in the stack. Okay. So who will push the calling program? This is very important. Which program you are executing? That program only asking, I want to enable the system call. Okay. Because this program only is having what? Having the input statement. Okay. So the calling program, this is the program which calls. Okay. So the calling program pushes the parameters, 3 parameters. These are 3 parameters. Pushes the parameters onto the stack. Okay. So first parameter will be pushed and then second parameter will be pushed. Pushed means what? Synced. Why we are saying we should not say we input or we inserted and all, because this has the data structure as stack data structure. Okay. Stack may only push. When I want to add anything, push. When I want to remove anything, pop. Only the push and pop is possible. Okay. That's why it is push. Okay. So we push the first 3 parameters in a stack. That means we are storing the details of this parameter in the stack area of the memory. Okay, so that is first 3 steps. Fourth step, look at here. Here only, in the fourth step only, actual system call is getting enabled. The actual call to the library procedure. This is a library procedure for read. Okay, so the actual call to the library procedure is made here only. Okay, this instruction, this instruction is a normal call. How function will be there in one place, function call will be in one place in your program. Function call, when it is getting executed, the function procedure will be called. So like that only, it is a simple call. Okay, which call? It is call for the read procedure, because our system call is what? Read system call created by the calling program. Please understand, it is very simple. Okay. Then what about the fifth step? Now you see, you have to imagine, this is your program, this is your library header you added. Okay, how the system call will work. So from your program, it will go to the library file. Okay. So step number 5, somebody said anything? Anybody said anything, students? No. Okay. So step number 5, trap to kernel. That means the library procedure places the system call in the place where the operating system expects the system call. Okay. So where the operating system will expect the system call, it will expect the system call in the library file, in one address of the library file. Okay. So what is step number 4? Step number 4, as I said, the actual system call, the library procedure system. This is calling this. Okay. So system call to the library procedure is made. This is a very normal system call. How within the program, the user defined system call will be same. Like, okay. What is the fifth one? The fifth one is the library procedure. This is a library procedure. Places the system call number. Each and every system call will have its own unique number. Okay. So that will be there here in the table. This we will discuss. Okay. So the library procedure, that is this one. This entire thing is called a read library procedure. Okay. So this read library procedure places the system call number in the place where the operating system expects it. That means it will be generally in register, but not in all the cases. you have studied the instruction register, no? So it will be inside the instruction register. So system call number will be put inside the instruction register. Okay. And then step 5. In the step 5 only, the library procedure executes. I said, no, every system call will create the trap instruction. Okay. So the library procedure, then it will create a trap instruction to switch from the user mode to kernel mode. Okay. To switch what? To switch the processor from the user mode to kernel mode. Till now, here this entire space is user mode or user space. In the user space only, everything is happening. Okay. But once the trap instruction has been created by the read procedure, that trap instruction will switch the processor from the user mode to kernel mode. Now this highlighted this, no, this is the kernel space. Okay, so if anything is working inside this, that is working in kernel mode. Processor working inside the space, that is called kernel mode. Now right now processor is in kernel mode. Okay, I repeat the step 6. The library procedure executes a trap instruction for the read system calls trap instruction. Okay, or what? To switch the processor from the user mode to kernel mode. Okay, so that's why the arrow coming from here to here. Okay, and then now step number 6, what is happening? The library procedure, that's what we saw, this execute the trap instruction. And in the step number 7, the kernel, this is the kernel of the operating system. Okay, see, don't confuse. Kernel is a set of programs which are very secured program of operating system. These are user programs of operating system. Entire thing is operating system code only. Okay. So the kernel examines the system call number here being in the kernel mode. Kernel part of the operating system examines the system call number and then dispatches it to the correct system call handler. So how it examines the correct number, the system call number, no, that will be there in the table. So this is the table. Okay. So here, if such a type of read system call comes, this is a system call unique number. If write system call comes, that this is the unique number of the system call. So that will be there, that information. This is a reference table. Okay. So the kernel examines the system call number, because the system call should be forwarded here from the kernel mode, because suppose there are 2 or 3 input devices connected. Which input device it has to, from which input device it has to perform the read operation. Okay. So for that, this analysis should be done. Okay. So the kernel, it will examine the system call number and then it dispatches to the correct system call handler. Then the system call handler will handle. That means here actual execution will happen. Okay, processor will execute the read here actually. Okay. And then by analyzed and given the system call handler will run. Actual execution will happen here. Okay. After that, the operation will be completed. Okay. And the user is given to, because here, from here it came, no, from user mode to trap instruction, switched the processor from the user mode to kernel mode. Okay, now the operating system is also, when processor switches means operating system will also switch from the user mode to kernel mode. Okay, and then here whatever it has, this is simple system call. You see, it is calling here, it is coming, performing the instructions, and then it is going back. Okay, where it goes back, from where it switched, to next statement of that. Okay, So even in your program also function call will be executed like that only. Okay. So it went to next instruction. Okay. And then the operating system has to clear the stack, whatever data stored for this this system call. So everything, the data will be cleared from the stack, because stack may have na ID, buffer, n bytes. Now using these all, we read the data, then we have to clear this. Okay. After clearing this, here the stack pointer will be incremented by 1. That means that will denote the next instruction which is going to be executed. Like this, the entire system call will work. I repeat because this you should know to explain. Okay. So 1 to 3, the program pushes the required parameters to the stack. Okay. Remember, in the read, first and third parameters are values. The second one is the address. Okay. And then in the fourth step, the actual call to the library procedure will be created. This instruction is very normal system call, how it will work like that. It's not system call, function call. The same way it will be executed. The library procedure places the system call number in the instruction register. Okay. It puts the system call number in the instruction register. Okay. The library procedure, step 6, the library procedure executes the trap instruction. The trap instruction will switch the processor from the user mode to kernel mode. So from user mode to kernel mode it came. Okay. And then the kernel examines the system call. The kernel will examine the system call number and it dispatches. Okay, that is this is called thread. We will see that later. Okay, what is the thread concept? Okay, so the dispatcher thread will examine the system call number and then dispatches to the correct system call handler. This correct number is given in the table of the system call handler. Okay, handled, this will be generally pointer. You know, in C you studied pointers. Okay, it will be in a pointer. The system call number will be pointed by the pointer. Okay, so the system call handler runs and then the operation will be completed. Okay, and the user given back the control once again after executed the trap instruction. And then the procedure, this procedure returns to the user program like how all the normal library files, library procedures returns like that. And then it will clear the stack because in the stack all these 3 are there. And then the stack pointer will be incremented by 1. Okay. So like this, the system call will be executed. This is little what we have to remember. Little lengthy. Okay. We can say easily the system calling program will create the system call that will create a trap instruction. And then the processor will move from the user mode to kernel mode and execute and then it will return. That's it. Okay. But internally all these will happen. Okay. So, and then there are many types of system call. Here we saw only read system call, no? So like this, many because operating system perform many services. Scheduling is an operating system service. In the scheduling, what it does, scheduling, there are many processes will wait to use the CPU. Operating system will schedule the processor to any one of the processes in the queue. That is called scheduling, no? So that is the work of the scheduler in operating system. Okay. So scheduling is one of the services of the operating system. File management. File management is hard disk management, because hard disk, inside the hard disk only our file will be saved. No, files are saved. So file management is another service of the operating system. And then main memory management. File management is a secondary memory management. Main memory management is another service of the operating system. Resource management, which is very important, that is another service of the operating system. So there are many services of the operating system. Okay, so whenever each service will be called, that means the operating system should execute a particular service. It could be scheduling, it could be resource management, it could be file management, anything. When it is executing, it should create the system call. Okay, so there are many category of system call. For example, process management. You can create multiple process. Okay, how all the multiple process is getting executed simultaneously. That is because of operating system. So operating system, when it is handling the process management, there are many system calls which are called process management system calls. So what I'm coming to say here is there are many category of system calls. Just only one system call we saw. Okay, there are many categories of system call. Those categories are depending on the different services of the operating system. That's what simply I came to say. Okay, because when I'm saying service, please don't confuse. There are many work, task, different type of task the operating system will do. One is process management. So how it will do process management with the help of many process management system calls. Okay. Then another service of the operating system is file management. How it will do the file management service with the help of many file management system calls. Okay. So like this, there are many system calls: file management system call, process management system calls, resource management system call. But I have given just 2 because you have to know just a category of system calls. That's it. Okay, so now process management system calls, creating a process, child process. Parent process is created. It has to create a child process. So it has to create a system call. Okay, that system call name is what? Fork. Okay. Fork is a system call. This is in Unix and Linux. Okay, under the POSIX system call. Okay, so when we are taking the Win32, then this will differ. It is not fork. Okay, it is create process. Okay, so the name of the system call will vary operating system to operating system. Students, you have to listen. Okay, you have to listen. And then if I have to delete the parent process. For that, the child process should be deleted first. So that time, the system call, one system call will be created. That is called the wait PID, process ID system call. Okay, wait for the child to terminate. Okay, so if the child is terminated, then only the parent process can be terminated. Okay. Like that, there are many system calls. Execute another program. This is nothing but context switching. I said, one process will be executed by the processor. Any new process comes which has the high priority process. Okay, the interrupt will be created. The operating system will, because recently came that process, that process has high priority, which means immediately it should be executed by the processor. So there will be a context switching. The process will be, the currently ongoing process will be switched to the main memory or the secondary memory, and the new process will come to processor. Okay, so for that this system call will be used. Then exit is another system call, which is process related system call in POSIX. Okay, terminate process execution and return to status. Return status. When any process is terminated, its status should be updated. No, we saw, you remember, there are 3 process will be in start state, reading state, different states where each and every process will be there. Okay, So that state will be updated. Okay, so these are just examples for process management system call. We have file management system calls. For example, if suppose now we saw read, okay, from where it read from a file. Okay, so before, if you want to read anything, any file, the file should be opened, no? So that is this system call, file open system call. And then after, suppose to update something, you open the file, you updated it, then you will close the file. That time close system call will be called. Okay, when you read the content of the file, just now we saw read system call. When you want to write anything in the output device, so write system call. Okay, so you want to keep the suppose in your hard disk, currently the read write head is in one position. Okay, it has to move to another position to access another data. So that is seek system call. So like that, this is status. Okay, get the file status, whether the file is opened currently or closed or terminated or having bug. So that. Okay, so like this, there are many system calls. We saw only read system call. That's what I said, no, Win32 has thousands of system calls, whereas Unix has hundreds of system calls. Okay, so like that, so many number of system calls. Using the system calls only, working on user mode to kernel mode to user mode, this and all will happen. System call will be created. Okay. Why, you may wonder why, ma'am, why unnecessarily all the system call and all, you may wonder. But suppose the program, we saw the main use of the operating system is giving the protection to the hardware. Okay, the system call, kernel mode, user mode, nothing is there. What will happen, no? As a programmer, you can write the program to corrupt the hard disk, to corrupt the input device whichever connected currently. In a single program, I can write. Okay, so my program will completely collapse the hardware. Okay, but hardware are very costly, precious. It should be protected, no? So for that only we have what? We have this kernel mode and the user mode. Okay. When any hardware corruptible instruction should be executed, then the operating system will go inside the kernel mode and it will switch the processor from the user mode to kernel mode. So this will protect. So now user being in the top level, they will think that, okay, I'm directly, my program is touching the hardware peripherals, but it is not like that. Only operating system will transfer the data through the system call. It will verify the system call is true or not, and then only it will allocate that. I said, no, unique number will be created. So that valid number should be there in the table. So there is one checking before accessing the hardware device. That checking is called system call. Okay, that is that simple as that. Okay, don't confuse. Okay, so that's why we need the system call. Okay. Okay. So this is very simple. See, if you want to inside the classroom, you have to behave in one way. Okay. At home, you can behave in another way. Okay. At home, you can be very free, but when it is coming in the official environment, in your academic place, you have to behave in another way. You have to behave, matlab, you have to follow some protocol. Okay. Suppose immediately you want to dance or you want to do something which you cannot do in the campus, education campus. What you have to do? You can do or what? No, you have to go to home and then you have to do. Like that only here also, the system call will move the processor from the user mode to kernel mode And being in the kernel mode only, that sensitive instruction, which should be very secret, protected instruction that can be executed by the kernel, executed by the processor, being in the kernel mode only, not in the user mode. User should not see. Otherwise, user should corrupt the, they can damage the hardware. Okay. So these are types of system call. Students, is this clear? System call, example of execution of read system call. And you should remember there are many category of system calls. Okay, why category? Why? What is the need of the different category? Because our operating system is not doing only one task. It is doing many tasks. What are those? Process management, memory management, file management, scheduling. Okay. So each and every process will have a set of system calls. Okay. Okay. I hope this is clear. If you have any doubt, you ask me, because everywhere we will use this. Students, first of all, are you all listening? You listen me. If you listen, then only you can understand. You just logged in and then you went away and you did some other work, and then you will not understand. Okay. I repeat again, any time I may conduct your internal class test. That means officially, of course, one class test will be conducted for this semester. But before that, I may conduct any class test which will not be informed priorly. Which will not be informed priorly, because this is to test that you are regularly attending the lecture, you are concentrating, you are listening when we are teaching. Okay. So any surprise internal test will be given at any time, which will not be informed. You should be ready. If you are absent for that, no retesting. I will not conduct retesting, but at the same time, I will include that as a part of your internal. I will not omit. So if you are absent for that, you will get 0 in that place, in that particular component. Remember. Okay. Operating system is very important subject. Okay. One second. Athar, are you there? Athar Kaifali. Are you there? Why? What happened? Many students did not attend the lecture today. Kaifali, are you there? Do you have any doubt? I want to ask that. Or others, if you have any doubt, ask me. Okay. Any one of you, please remember, Parvati, you have to inform to Glory. She has to contact me regarding the literary events. Okay.
Yes.
Okay. Next, we will move to different types of structure of operating system. Structure of operating system. Okay, wait, I did not share up. Structure of operating system. This is very important. Okay. There are 5 different structures of operating system. Structure of operating system, matlab what it would be. The code, operating system is code, program, one or more programs. I can't say program. Okay. Because why I'm saying one or more programs, because some of the structure, no, operating system will have only one program. That is our monolithic systems. So operating system is nothing but a program. Okay. when I'm saying OS structures, that means the different structures of that operating system code we are going to see. Okay, how the code structure of operating system, that only we are going to see. Okay, this you have to remember. Okay, so usually when we are talking about structure, no, it will be structure of some hardware, okay, or some design. But this is not like that. This is just a structure of coding structure. Some of the code, for example, if else, RIA, if else loop will have different structure than switch loop, case. Okay, because switch case, no, parallelly it will call more than one number of operations parallelly, not one after another. Okay, but if then else will call one after another sequentially. If this is true, this, and this is false, this, that. Okay, so the structure of the code will be different. Okay, in the operating system to operating system. That is what we are going to see here. The first type is monolithic operating systems. Okay, monolithic operating system is very obsolete nowadays. Nothing, of course, DOS operating system, DOS. So that is disk operating system. No, that is monolithic structure. That has monolithic structure. CP by M. That is another type of operating system. That is also that also has the structure of monolithic. It has a monolithic structure. Okay. Monolithic monolithic operating system code will be like this. There will be a main procedure. How in your C program you have a main function like that, main. So that is the there only it has the complete control. The execution will start from there only. Okay. So there are many procedures in the monolithic system. Those procedures are categorized into three. One is main procedure, others are service procedures and utility procedures. Okay, you can imagine in this is like a control, centralized control. Here nothing. Okay, main. From here parallelly there are services connected. Here the program structure will be like this. Okay, you can imagine when I am saying service procedures, this could be scheduling service, this could be file management, this will be process management, this will be main memory management. Like that you can imagine services, different services of the operating system. To accomplish each and every service, there are many helping other procedures which are called utility. That's why we are calling this as a utility procedures. Okay, so one service procedure may connect with more than one number of utility procedures. Okay, these utility procedure, for example, this is scheduling. Okay, so to do the scheduling, any helping services, any helping task, it has to helping activity, it has to do. For that, there are two utility procedures. Okay, maybe one could be clearing the queue. Okay, once the scheduling has been done. Okay, then other could be adding the new program in the multi-programming system. So these two utility programs are what? Small task, not like this. This is complete service, complete schedule service. So this is service, this is utility. Okay, so these utility programs can combinedly help to complete the service. Okay, so it is not necessary one service procedure should be connected to only one utility procedure. It can connect with connected with more than one number of utility procedures also, or only one utility procedure also. At the same time, some of the services will not have any utility procedures. It will it will perform everything on its own. That is also the case. Another case is only one procedure may have only one, may need only one utility procedure. Other point is only one utility procedure may be used by more than one number of services also. Look at this example. Okay. It is not necessary if suppose these two utility procedures are used by this service. So this should not be used by other services. No, it can be used by other services also. Okay. Here you can imagine the main control, for example, your main function. Here you can imagine the each and every, for example, there is a function, okay? Function ka andar a complete logic will be there for what the function has been created. So scheduling, and this is anything else, file management, like that. Okay. So this I said examples, okay, for schedule. So now you can imagine how the monolithic operating system will be. Main thing is the monolithic operating system has a single program as an operating system program, single, only one program. In one program, that's a big, very big program, millions of lines of program, but everything is in a single program. Everything will work in a kernel mode, no user mode. The entire big program will be executed in kernel mode only. Okay, once again. Okay. Okay, students, I did not complete the monolithic system. Okay. So we will end here because 5 minutes also more I extended. Okay. So we wind up now today's
Hello,
lecture.
ma'am.
Yes.
Ma'am, you are not gonna share this PPT even at the ending of that of this topic.
Ending.
Ma'am, yes, ma'am.
Huh.
After you teach, after you finish teaching all, cause it would be easier for us to like collect the notes and manage them. If you share the PPT, like we will make the notes properly.
No. After completing the chapter, of course, because this one PPT does not have everything. Okay. Only
Okay.
one chapter. Chapter wise PPT only I have. After
Okay, ma'am.
completing a chapter, I will share.
Okay, ma'am. Thank you, ma'am.
Okay. And did you see the files folder? I shared the syllabus and the book. I don't remember PPT I shared or what. So you please check Teams ka files folder. Okay. Kaifali, now only you joined. Before this, I call you. You did not respond.
Ma'am, actually, I had some network issue in my area. Geo ka network issue. There is something. That's why I was not
Okay.
in the meet.
Yes, ma'am. From 2 to 3 days, there is a problem due to some electric issue. Geo tower.
Okay. 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 That's okay. So this PPT is actually you can get from the net also, because this is the PPT which is Tenenbaum book ka official PPT. That the previous one, the units, chapter 1 I can share, but it has other content also, many other content also, which I yet to explain. Okay. So I
Okay,
thought,
ma'am.
or otherwise, whatever I completed, I have to upload, and then I will upload that PPT, which will have any hardly 15 slides. Okay, so that I can do. Okay, so whatever I completed till today, no, that I will upload, and then later, then I have to keep on update that particular PPT, which I uploaded already. Okay. Okay, the book you
Okay, ma'am.
asked, that I shared already, I uploaded
Yes,
the
ma'am, got
files.
it. Yes, ma'am, got
Okay.
it.
Anything else? Any material I uploaded? I don't remember because SYK materials also I uploaded. Any PPTs or anything I uploaded? Anybody saw? Okay, let me see. Okay. Okay, students, your exam will be definitely offline. Okay, your practicals and theory exam. Okay. So we will start your offline lectures soon. So why I'm saying this, you have to prepare all the subjects accordingly. Your exam will be definitely offline. Physically, you have to come to college and write. Question paper will be given, you have to write.
Ma'am, you have uploaded interrupt-driven IO ka image and
Okay.
programmed IO ka image, and also the syllabus and the reference book.
Okay.
Yes, ma'am.
Okay, so you start to study, please. I'm saying you start to study. Otherwise, operating system and all, if you did not study, many of you will fail. I should not say, but I have to say. Okay, if you did not study starting from the first, it is very difficult for you. Not studying, you have to attend all the lectures and you have to listen also. Okay.
Yes, ma'am.
Okay. Okay, thank you, students. You all can leave.
Thank you, ma'am. Bye.